Hello, data enthusiasts. Welcome to the Everyday Analyst, where we simplify data one byte at a time. If you're just starting your journey into SQL and databases, you are in the right place. In this video, we'll cover the fundamentals of databases, what they are, the different types, the difference between OLAP and OLTP systems, and finally reveal which SQL database we'll be using for this whole series. Alright, let's dive in. What are databases? A database is simply a structured way to store, organize, and manage data so that it can be easily accessed, updated, and retrieved whenever needed. Well, this was more of a bookish definition, but you can think of it as a digital filing cabinet where everything is stored in an orderly manner, making it quick and easy to find exactly what you need. Now, what makes databases so powerful? Let's look at their key features. They store and organize data efficiently. Multiple users can work with the data at the same time, ensuring smooth operations in businesses and applications. Databases ensure integrity, prevent duplicate or incorrect records, and keep data safe through backups. Data is protected with user access controls, and they can scale from small applications to handling massive amounts of data for enterprises. Databases power almost everything from your favorite social media app to online shopping sites and even financial transactions. But not all databases are built the same way. Now that we know what a database is, let's explore the two main types of databases. That is, relational database and non-relational database. Relational databases store data in tables with rows and columns like an Excel sheet, but way more powerful. Each table holds a specific type of data, and these tables connect to each other using relationships. We will learn more about the relationships between tables in the future videos. Examples of relational databases include PostgreSQL, MySQL, SQL Server, etc. SQL databases are great when the data needs to be highly structured and consistent. That's why industries like finance, healthcare, and enterprise applications rely on them. On the other hand, we have non-relational databases that store data in flexible formats like JSON, key value pairs, or graphs, making them ideal for dynamic, fast-changing data structures, especially in modern applications dealing with large, fast-moving data. This makes them perfect for handling unstructured or semi-structured data where relationships between data points might change over time. Examples of non-relational databases include MongoDB, Firebase, Cassandra, etc. These databases are used in social media, real-time messaging, recommendation engines, and a lot more. Since we are learning SQL, we'll be working with relational databases throughout this series. But relational databases aren't just used in one way. They power everything from real-time banking transactions to large-scale business analytics. That's where the difference between OLTP and OLAP comes in. Now, databases can serve different purposes, and you might hear two common terms: OLTP, that is online transaction processing, and OLAP, that is online analytical processing. The purpose of OLTP systems is to support day-to-day operations where speed matters, that is, fast, high-volume transactions. On the other hand, we have OLAP systems with a specific purpose designed to serve complex data analysis. OLTP systems deal with operational or recent data versus complete historical data in OLAPs. Therefore, there is a huge difference in the size or volume of data that they operate on. OLTP systems typically have volume of few hundreds of MBs to a few GBs versus few TBs to petabytes in OLAPs. Since OLTP systems handle day-to-day operations, the response for these systems is in milliseconds. That's very fast. And on the other hand, we are focused on analyzing trends and finding insights on huge data where response time is few seconds to a few minutes. OLTP systems need both read and write operations, and OLAP systems primarily do read-heavy operations. Finally, OLTP systems are used in banking, e-commerce, or ticket booking systems where transactions happen instantaneously. OLAP systems are used in business intelligence, dashboards, and big data analytics where you need insights, not just transactions. Some databases are designed specifically for OLTP, while others are built for OLAP. But there are also databases that can handle both, powering everything from daily transactions to complex analytics. For this series, we'll be using a relational database that gives us best of both worlds. Let's now discuss which database we will use and why. There are several relational databases out there, but we are going to use PostgreSQL for this series. So why are we choosing PostgreSQL? It's free, widely used, supports advanced SQL features, strong community, cross-platform support, and fully SQL compliant, making it an ideal choice for learning SQL without restrictions. Plus, it supports both OLTP and OLAP workloads. So whether you're doing simple queries or running complex analytics, PostgreSQL can handle it. Now that we have chosen PostgreSQL as our database for this series, you might be wondering, what if I use MySQL, SQL Server, or Oracle in the future? Will I have to relearn everything from scratch? No, the good news is you don't have to. Because SQL is based on ANSI Standard SQL, that is American National Standards Institute SQL, which is a common language across databases. So SQL remains SQL. The fundamentals of queries, joins, and manipulation work the same across most relational databases. Once you learn it, you can use it anywhere. So if you understand PostgreSQL, you already know 70 to 80% of MySQL, SQL Server, or Oracle SQL. Therefore, it's easy to switch. What's different is the variations that exist in extensions, performance tuning, and database-specific functions. But the core logic remains the same. So don't stress about picking one SQL database. Instead, focus on learning SQL as a language, and you will be able to apply it anywhere. That's it. In the next video, we'll install PostgreSQL and set up everything you need to follow along and start writing SQL queries. See you in the next one. If you found this useful, make sure to like, comment, share, and subscribe.